Or there is basically three types of machine learning. So supervised machine learning, unsupervised machine learning, and reinforcement learning. But now we are going to introduce in a new machine learning. That one is semi-supervised machine learning because of artificial intelligence. So okay, in our this part we are learning about supervised machine learning. So in supervised machine learning, the model learns from the level data, like it data set, what it is, such as it is already provided the features name. If we are working with dataset containing the history of heart disease, features will be like the high blood pressure, sugar, cholesterol, like this. So I mean, while machine is learning with the supervised dataset, it knows that what the dataset is. So the process is whenever we give our model the data set, it is a process data, and then it will do the training split of training data set and test data set. The training data set will go, the algorithm will learn from training data set model. After that, it will go for the test data set, which remains unknown for the model, and then it gives us a validation. For this to examine the model, we in the next step we go for prediction. Here we give our model totally new data. From that, our model will give us some kind of predictions. So there are two supervised machine learning has two types. One is classification. This involves the predicting which category or class an input belongs to. The example is whatever we are doing, like SSD is failed or healthy, the email is spam or not. Like this is the classification. It's kind of the binary results. And the regression is it predicts the future result. Like by using the regression model, we can predict the next 7 days expenditure result for the next semester or number of the goals in the next matches of a club or of a country. So now what is data? Data is the most important thing for machine learning. It is a kind of book for the models. The first step we should do is data collection. Actually, we also produce data like our watching history, our search history, our buying, selling history. This is kind of data set. We can collect data in two ways. We can generate our own data set or we can download the data set from the open source data set. So this is the data collection for machine learning. And then we go for data pre-processing. Data pre-processing is the process of cleaning and transforming raw data before feeding it into the machine learning model. Real-world data is often incomplete, inconsistent, and noisy. It has some kind of missing values, null values, and some values are only zero. But the problem is zero is a meaningful thing for machine. So we cannot put a data set with a lot of zeros. And in data processing, we need to improve the model performance and accuracy. It helps the model to generalize better to unseen data set, and cleaning and transforming raw data into a format suitable for the analysis, what will be done by our models or the machine learning algorithms. So this is one kind of one picture of a demo data set. Like it has some kind of columns. It is for a supervised machine learning, and we know all of the features are labeled properly. But we can see there are some kind of data set like the school's name RGP and the family size the DT3, LE3, and then there is mother job, father job. There is total text data, which is totally impossible for the machine learning models to understand. So we need to do this. We need to handle this type of data set pre-processing for our machine learning model so that it can learn well, because that so far that much we can give a good data set to our machine learning model, it will give us a better result. So this is the step where we are doing the pre-processing thing. Like now we can see that the school's names, the column school have been changed from GP to like 0 and 1. It is getting some kind of value for their text data set. And if we do the whole pre-processing with the data set, we will get something like this. Here, the mother's job have some kind of value, father's job have some kind of value, regions have some kind of value, guardian have some kind of values. The numerical values before that, which was text data set. So this is the most important part we need to do for our pre-processing of our data set.
I'm sorry, what was changed?
I can see the mother's job, father's job, reason, they have some text values.
Can you go to the preview, the raw data? Okay, people. There is field, sex field, and this, what else?
The school, the family size.
Family size. Okay, I think the most of the text
Yes,
field.
they are going into the numerical values. So because machine could understand the numbers.
Okay.
And then the algorithms, like why we should give the algorithms or choose the algorithm, which one should our machine follow. Like in machine learning, choosing the most appropriate machine learning model for the specific predictive task based on the characteristics of the data, the type of the problems are being solved, and any project constraints or goals. Like if we are predicting what could be the next number of goals in the next match of the club, we cannot go for classification. We need to go for regression like this. So we need to choose the algorithms properly. Predicting categories like if the mail is spam or not spam is a classification problem. Algorithms models such as logistic regression, decision-tree random forest, support vector machine neural networks, they are do this kind of prediction things. And regression problems like predicting multiple values requires algorithm like linear regression, decision trees, gradient boosting is this type of algorithm. So after in our next parts, maybe we will learn elaborately about the algorithms.
Okay, can you make this slowly? Sorry, it's so hard to follow. Sorry.
Okay, then this is our model training. From the pre-processed dataset, we need to split the dataset into two parts. So we usually give the large ratio to for the model training, but the model is learning the structure, the relation between the features and the patterns for predicting the future results. And model testing, we normally give the smaller portion of the dataset, which remain totally unknown for the model, and the given for testing, which will give us the result. We do the evaluation with different type of metrics such as accuracy, F1 score, recall, etc. This is the methods by comparing with this with the results of this. We can compare different algorithms for our models.
무슨 말인지 알죠, 이거? 트레이닝하고 테스팅하는 거. 그치, 다 아는 거지. 미안해. Okay, yeah.
So this is the evaluations, the accuracy, F1 score, F05 score, recall, precision. There are more. We can choose our evaluation method based on our problems and data set. So for that, we need to learn the how we are doing the evaluations. This four is the main thing while we are doing the machine learning or predicting the things. This is the true positive, true negative, false positive, and false negative. So what are these? True positive is when the actual result is positive, and also our machine is predicting that this is positive, then this goes for the true positive. Suppose the SSD is failed SSD. So our machine also predict that this is a failed SSD, then this case will go for the true positive section. But the SSD is failed, but our machine is thinking that this is a healthy SSD, then it will be go for false negative. And suppose the machine is the SSD is healthy, but the machine is predicting that the SSD is not healthy, then it will go for false negative. And if the SSD is healthy and machine is also thinking that the SSD is healthy, it is predicting that the SSD is healthy, it will go for the true positive section. So with by using this four, we will go for our evaluation metrics. So this is the things we should keep in our mind while we train our models with the dataset. The first thing is overfitting. Overfitting is the machine learns too well, but when we give our model the test dataset, it will give a very poor result. Suppose I have studied so well, still I am getting the poor marks. This is causing the overfitting. And underfitting is machine cannot learn well, so it will never give the best result on the dataset. Suppose the subject is too hard for me, I couldn't even learn and I couldn't even get the marks. But what is the good fitting is when the machine learns well and it is giving the perfect results for the test data set. Suppose you guys studied well and you are getting good marks. So this is the good fitting. So in this part, we will learn about one machine learning algorithm. This one is the k nearest neighbor algorithm, or KNN. This is this is the most core basic algorithm, and this is the most easiest algorithm in machine learning. So that's why this is in our first part. So it is a non-parametric and supervised learning classifier which use proximity to make classification or prediction about the grouping of individual data point. And in KNN, the value of K is very important. So like in KNN, we will have, if we in our previous slide, we know that in supervised learning we know what is the data. So whenever an unknown data will enter, we need to find that it will be like here we have two types of data. One is the class A, one is class B. So when the unknown data came, we need to find that if this data will be go for class A or class B. This is what done by the k nearest neighbor algorithm, or KNN. So here we need to find the value of K. Suppose we will choose that the value of K will be 5. For this, we to the unknown data, we need to make a circle and we need to put 5 data in the circle. So so 3 data in the circle. So after creating the circle, we need to see that how much ingredient came from class A and how much ingredients came from class B. The highest number of the ingredients from each class could be the result for our new coming data set. Such as we can see in the while the value of K is
I'm sorry.
can I use the markers?
Yeah, sure. I mean, yeah. 그래, 오, 예. 하자, 저거. 응? 뭐야? 저기 쓰고 있는 거. 네, 맨날 봤잖아.
So when we
Yeah. I like red. Passionate.
when we put the value of K is 3,
Uh-huh.
and we created a circle, we need to put
together. Maybe when you place there, maybe they cannot see your. But in the video, I think we cannot see any. Your note it will not be recorded, I think. But it's okay.
does not have the
Yeah. Okay.
so
So,
should I just
yeah.
so when the value of K is set for 3, so we are making the circle, and from class B there is 2 ingredients, and from class A there is 1. So this is the unknown one. We need to predict which one would be this. So by this value of K, we can think that there is 2 from class B and 1 from class A. So which one could be our new one from class B? But if we put the value of K 1000, so then the circle might be like this. So we cannot find which one it could be, right? So in this case, it is like what is like overfitting or underfitting?
Overfitting.
Actually, it's going to be underfitting because our machine cannot learn.
I cannot learn.
Yes, cannot learn because everyone is coming in the circle like this. But when we putting the value 3 or 5, this is kind of good fitting. Like how much, like this. So, but the thing is,
if you wanna erase can you touch the
hands. So can you draw something, for example?
This.
In that case, you will erase all of them. But can you draw something? Anything is fine. And can you love the no with the hands? No. Yeah, with the palm. Yeah.
Oh.
Yeah.
I don't know the features.
Yeah.
So,
But I'm a little confused. Confused. So what is the meaning of K? This K of the how many we can make the group for the for the for classification? As I understand, the K is the how many group we can make.
This is the unknown data set. I mean the unknown data which entered. We need to there is also I didn't include the mathematical terms here. So there is the distance from it should be in the center.
Okay.
And the thing we are taking, the distance must be same for all. And K is like the okay. So K is like what we call it. Like we took the variable. We are taking the variable to find our unknown data. But sometimes it's like so. Like if we are predicting something new, suppose the students of our lab, there are Koreans and we foreigners. So what could be the Korean? Suppose one student enters A. What could be his or her features? He is speaking in Korean and he is looking like Korean, so they are going in this portion. But when the foreigners came, they are not speaking in Korean and they are not looking like Korean, like this. So when a new student will come in our lab, so if he is pointed here, he or she.
Okay,
So they are the Koreans and they are the foreigners.
so there is two
classes. Okay, there could be more classes like there is Bangladeshi and some other countries, like this. So if a new student enters and he is pointed here, what could be Korean or Indian?
Distances look like the same.
Yeah. So for this, if we put the value of K3, so it is going for this. Still we can find.
No.
So this will go for overfitting. Sorry, underfitting. And
okay, I think.
I think you will understand.
Yeah, we can understand.
So this is good. Yeah. So I just included this in this much in our machine learning part 1, and I also added the codes for in our. Probably should I go for the codes?
I'm sorry,
Should I go to the codes?
I don't understand what you're saying.
Coding.
Yeah. You mean, is it done for the lecture? I mean, kind of seminar? Then okay, yeah, we can move on the practice. 실습 뭔가 해서 알려줄 거예요. 과제는 아니야. 과제는 아니고.
저의 사람 가져를 줬어. 네, 고.
아, 조배다가 과제를 줄 수도 있겠다. 내가 그런
네.
권한이 있는 게 아니야. 조배다, I think you could give an assignment for the students.
Let's go.
Yeah.
That will be, I think, maybe you give the assignment.
No, because you are the lecturer.
Of course not, never. So there, our professor added some books for you for learning the machine learning, and there is another PDF I also included. But if you need from the rather than the book, you can go for this. And there is the practice code in our GitHub.
네, 이거 초대해 줄게요. 여기 페이지.
프레임.
박사원 정리 잘했네.
오.
So there is
Have you written by yourself?
our professor. This is written by me in 2023.
Okay. Wow. Okay.
Good.
So there we are using the Irish dataset. This is the most common dataset. Whenever we are started learning machine learning, we go for this dataset and this type of task. So where there is all of the explanations here, what could be the domain set, what could be the level set, what could be the training dataset. So I would like that you guys should go through these and understand, and also you will not understand something and ask me or professor like what is this, what it should be, like this. And there is the codes. You by running them you will get the outputs, and you just need to know that whatever happening in this line and whatever is coming in the output, like it is also written like what is happened there. It will load our data set, and what will be done here, it will print the type of the data set, and what will be done here, it will predict, or it will show all of the columns of our data set because it is a level data set. And what is done here, it is showing all of the data from the data set. And so it is also written here, like what is happening, like features, what is happening by this line of the course. It's printing all of the features name, and it's printing the targets name. Actually, this dataset contains features of different kinds of flowers, but these flowers go for three classes. They are these: Setosa, Veriscala, and Virginica. So from learning the patterns of the flowers, we need to know that which could be the flower. Like it could be the class A, class B, or class C, like this. So I think you guys can download this file and run. This is very simple. You will understand. You just need to know what is happening in the code and what is happening in the output, and it will predict the error, the accuracy, and the class name also. So try this, and
바로 하실 수 있어요.
so try this, and maybe in next Thursday, let me know how much you understand, how much you didn't understand.